I thought I'm going to start with a little introduction of myself, and I thought I'll do that by showing a couple of works that I've been done or that I've been doing. So I'm a professor at the Film University in Babelsberg since last year, May, so 1 year now. And what I'm doing or what I'm interested in for the past 12 years now about is the visualization of data, but in a more artistic sense, in a more like I'm also questioning the data sets quite a lot, the things I'm doing. So this is a piece, a very early work that I've been doing or that I've done. And I like to start with it because it's easy to explain. It's easy to give an introduction of data visualization and its capabilities. So what you see here is basically a tree diagram of all the billionaires that we knew of in 2012. And oftentimes, how this data exists is in a list of a website called Forbes, and they create this list and they put it out, and you can see who's like the richest person and who's the second rich and so on. And I took that data and basically reorganized it. And I said, I made this algorithm that's branching out. So what you see is first all the countries. And then on the second layer, you see the areas they made their money in. And then you see the billionaires themselves. And by doing so, by transforming this data set into this structure, suddenly this like patterns emerge. And like what you see is like this 1/3 of this tree diagram that is basically the United States. And then you see this big like bubble on the left, and that's banking in the United States. So suddenly we have like we're shifting the perspective and something else is becoming visible. Here's a bit of a zoomed in version of that. And we can see like the colors indicate if somebody made that money by themselves, then it's blue, or if they inherited that wealth from their family. So suddenly these patterns emerge that in some industries, basically it's all the wealth is inherited and it's given from family to family. So that's like one notion, how data can then help to make stories visible, to show things that otherwise stay hidden. Then on a very different scale, this is an interface I made. I worked with a couple of physicists for some time, and I made this graphics of the largest structures of the internet, not the internet, the universe. So each point is basically one galaxy. So the entire Milky Way is basically one point within that model. And for the scientists that worked on this, it was like important to have the sliders and to filter out certain or based on certain parameters. But here you can see like this is something that lives online, so it's based on WebGL. You can search for cosmic web. And you should find the visualization and you can explore it on your own. But at the same time, I'm also doing things that are more a bit artistically. So this is a theater performance I was involved in. It's called The Hairs on Your Head Are Numbered. And basically half the audience got a glove, and we tracked the heartbeat throughout the theater play, and the entire play became about the people in the audience and how they reacted. And we had all this visualization showcasing like how people actually, how fast their heartbeat went and when it became faster and slower. And the entire play was on that. And then also like things that are more like artistic, where I'm questioning this notion of the network and where I'm drawing not the network itself, but the paths in between the network, the places where the algorithm went, but which is not the algorithm itself. And last but not least, a project that I'm currently still researching and that I'm working on. This is called Artificial Worldviews, and it's basically a discussion that I had with ChatGPT, where I requested about 1,800 data sets from that system, and on the topic of what is knowledge, and visualize the results. And what you have is like this map of all kinds of weird things, going from like people like Plato to like concepts in the world, and also the connections and how the things are related to one another. And through that, like interesting patterns emerged, and it was still quite a big of a project that I'm working on. But this is, I think, enough about myself. And now we will start with a very first thing, and you will have now 10 minutes to find as many ways to visualize these two numbers. And the question is, or the task is very open, but take a piece of a pen and a paper, and try to draw as many visualizations of these two numbers. So we have a little bit of a mosaic of like stuff that happened within the last 10 minutes here. Like there are multiple things that I love about this task. Thank you all so much for joining this. But what I find so fascinating, I mean, we have a data set of like two numbers, which is like the most reduced thing that you can have. So interestingly, you also, to visualize something, you need two numbers. So because if you only have one, basically you can draw a circle, and that circle can mean anything. It only becomes meaningful if you have a second number that you put into relation. So data visualizations, as a very core, at the very essential, they need some kind of like relational value to something else. So that is something I think that is super important to always keep in mind. And then this task of like mapping from like some given value to something else. And then thirdly, what I always find fascinating, I've done this task like many times, and normally I'm doing it like in workshop settings, and we're working with like this like Post-its, and then we have the whole wall full of Post-its. And what I like about it, and what I find so fascinating, is that even if you have like this tiny data set of like two numbers, there's so many ways to represent that and work with that and use it. And that is kind of interesting, that even if we have something that is so reduced, we can do so much with it, and there's so much creative freedom to use and work with. And when you were showing your pieces, I saw a lot of like pretty interesting versions, and that is for me something that is pretty cool, that you can do so much even if we have like a data set that is so tiny. And the data sets that we will work with will grow, and then there you have even more possibilities and things that you can do. Okay. So we're not the first ones who've done this, and here's some other examples. This is something I've done over and over the past years, and it's interesting. You oftentimes see that the same things are coming up again and again, but I always see also new approaches to this and new things. And oftentimes, the longer I leave for this project to happen or for this process, the more abstract things become, and the more wild the approaches get. So one thing that I just wanted to quickly share is like a little bit of the visualization design process. So, and I think that this is like really important to understand like what visualization is actually about. And we will not get into the nitty-gritty and the details, but just to give you a little bit of an overview. So, and one way to think about what visualization is doing is what we just did. So you take some like some form, it's given like in this notion of data, and you translate it into this visual variables. And I think that is what's happening if you visualize data. And oftentimes data can be thought of in like this kind of hierarchical structure. So it normally comes either as something that's numerical or that's categorical. And that is what you often see. I mean, there are more nuances to this, and it becomes more complex if you dive deeper into this, but that's a very good overview. So when you have like something numerical, I could describe myself in like the age I'm how old I am, how much I weigh, or my shoe size. You can think of like other things that you can describe yourself in, or like things that are more categorical, like the eye color, gender, blood type, etc. And then within those two things, there are more nuances within that. So you can have things that are continuous. So you can have any weight or any height. But then, for example, shoe sizes, they only come in specific sizes. And you can't have something like half a kid. It's very difficult. And the same thing goes for categorical data. So they're different. They're ordinal data that is like they have some kind of rating to them. So or like, is your mood, is it like good or bad? And then you have nominal data. There's nothing like a better eye color than another one. So there are like this ways you can distinguish data, and based on those distinctions, on how you determine what kind of data I'm dealing with, you can do other things with it in your process of mapping things. And when it comes to mapping, most probably, like we have a lot of like creative students, so you know about these things, but this is basically the very foundations. It goes back to a person called Jacques Bertin, and he tried to, on the one side, like map out what are the different kinds of symbols that we can have. And he says there are basically three main categories. They're points, lines, and areas. And then there are all these different things you can do with them. You can change the size, you can change the opacity, you can change the pattern on them, you can change the color, the orientation, and the shape of these things. So, data visualization at its very core is like of the translation from this data into these and trying to find either good or interesting or experimental, expressive ways to transform the one thing into the other thing. If there are any questions about this, please feel free to just say something. And just to mention this, there's a lot of like research on like what works good. So people spend a lot of time figuring out like, oh, how can we use what kind of data to do what kind of thing? And just I just going to give you a very brief introduction to this that we can also do interactively. So, and a lot of these things on visualization and perception come from like neuroscience and psychology. So my first question, how many sevens can you count within this representation? The thing is, it's a very hard task. It takes us long to do this. If I now like redraw the same thing with the sevens all highlighted, suddenly it becomes something that's very easy. And I think this is a common thing in visualization. So you always ask yourself, okay, what is important? What do I really want to highlight here? What is the thing I want to showcase to people? And that can then make a huge impact on how you represent something, how you showcase something. And suddenly something that is very hard and you need to go through from line to line and count all of them becomes very easy. Same thing here. In the first pie chart with the letter A, which color is the biggest, has the most area attached to it? So now underneath, I'll show you the same data in a different representation. And suddenly, it almost sounds silly if I ask you which one of the rectangles is the longest. so just by changing the shape or changing how we represent something, it becomes very easy to read. In the second pie chart, which one is the biggest? Which one has the biggest area? So it's pretty tricky, we can see. And that's why a lot of like data visualization the designers hate pie charts because they're so difficult to read. So this is the same data set represented in a bar chart. So yellow was right, but all of them are very close. And then we can also do it for the last one. You're pretty good at um, at seeing pie charts, it seems. Nice. Yeah. So, and this is not only true for the comparison of bar charts to pie charts, but this is true for all kinds of things. So here, for example, the visualization uses the opacity to display something, and then in comparison, the same thing with the size of the circles, and then again as a bar chart, it becomes very easy to see like the different sizes. And there's again a lot of like studies on this, on what to showcase and how to showcase it and how to make it visible well, and then what else can we use? But I think for this introduction session, I won't go into details. But what I will say is that there's also a counter argument that we can make, and that is often within data visualization design, I think, underestimated or overlooked, is that legibility, so how well you can read something, might not be communication. So this is a statement made by graphic designer David Carson. And he made this like super wild magazine layouts in the 90s and early 2000s, where everything is like messed up and you can almost not read the words, but that's the interesting part of it. So you don't need to make something, you don't need to use a bar chart every time you visualize data. But you can also use more expressive things if you want to communicate something else, or if you want to communicate differently. So that's just a side note to how I'm thinking about this. So, and now lastly, like the last thing that I want to show you before we go into another exercise is like, I just wanted to introduce like different forms of data mappings, because this can become quite important. So the first thing are numerical values, what you just saw with the bar chart. So you have something, you have like A, B, and C, and then you have a number attached to that, and you can represent this in all kinds of different ways. But there are also different data structures that we can look at and that we can work with and oftentimes they're also combined. So it's not always one thing, but it connects to other things. So these are examples of hierarchical structures where you basically have something that you say, hey, we have like a continent like Europe, and within that continent, there are different nation states, and each nation state has different cities within those. And then we suddenly have this like hierarchical perspective that we can draw out, and there are different visualization forms that you can use to represent that, then that you use to represent numerical values. And then like something that is oftentimes very difficult is to represent textual data. So if you just have a book, or if you're just having a text and you're trying to make visualizations out of that. But there are also pretty interesting ways of representing that. What you see here on the left is a visualization technique called word tree, where you can basically take an entire book and then you say one word and it gives you all the sentences and all the words that follow that word. So you can suddenly see structures within that and how much one word is used with accompanied by other words. Relational structures is like one of the core things that I'm researching or that I'm working with myself. These are oftentimes network structures. So if you have like, let's say a movie and that movie like references another movie, then you can connect those. And if you have like hundreds or thousands of them, then you can create these network structures and look at how the network actually behaves. And then there are temporal structures, which are like basically representations of time. This is the chart that you see on the left is from 1765. So visualization design is nothing that is like that just came into being very recently, but it has a long history. What you see on the right is a project called History Flow by Fernanda Viegas and Martin Brottenberg, where they basically found a different representation of articles on Wikipedia. And you can see within that graph, so like it's basically a representation over time. And you can see it's always one article, and you can see how the text changes and how content is added or removed. And when you have this like zigzag lines, that means that there were like a couple of authors that had like something called an edit war, where they fought if an article should be in an or if a section should be in an article or outside of an article. And then you have spatial visualizations, which are most probably the ones you're most familiar with. So representations of the planet, like Google Maps, or like any other globe that you have, or a map on your wall that we use to navigate, to come from point A to point B. I've chosen like a representation here of all the undersea cables that make up the internet and that allow us to have this Zoom meeting. Great. So now we'll quickly go into tools, and I will only mention this very briefly. So raw graphs is, you can visit rawgraphs.io. We will work with that tool in a second, because I think it's very intuitive, it's very easy, and you can make visualizations within minutes. So I think that's very helpful. Data wrapper is similar to that. It's a bit more professional. So data wrapper is used by almost like by most journalism outlets nowadays. So this is a real tool, but it's also relatively easy to use if you're interested in journalistic approaches to data visualization. This is quite a good tool. And then OpenRefine is like a tool to basically clean your data and to look into your data, less for visualizing it, but it can be very helpful to get an idea of what is in your data and how can you work with that data. And then if you're a little bit into coding, observable plot is a relatively new tool where you can, with very little code, you can do an expressive or impressive amount of graphics. Yeah, so that is observable plot. Here are some examples of what you can do with that. If you're more into like coding, you can, Pandas is a very good library for working in Python. And the tool that I'm using for most of my projects is called D3JS. So it's like this JavaScript library. It has quite a steep learning curve. So in the beginning, it's like it's kind of hard to get around, but it gives you a lot of freedom. And I think that's also how I'm thinking about this tool. So you have on the one side the tools that are very easy and you can do something very quickly, but it's also kind of restrictive what you can do. You're very much like it's pre-programmed, and then you have the tools that give you a lot of freedom and give you a lot of like possibilities, but that are also kind of hard to learn. So what I would like to do now for the next like 15 minutes is that you basically open rawgraphs.io and you find a sample data set, and then you create a visualization. So within the page, they basically have visualizations. Let me show this to you. yeah, this is the front page, and then you basically click on use it now, and then you get to something that looks like this. And here you have a couple of options. So you can basically put in your own data, and we will do this throughout the exercise. But for now, because we have a limited amount of time, you basically go to this like third option, try our data samples. And you can just pick something from here that you might be interested in. I can give you an example. So maybe I'm interested in the happiness index. And this is basically then a preview you get, and you can see, wow, this is a big chart, and you can see it has like a country. So it has some ordinal data, and it has like a couple of like numerical values attached to it. And then you can go down here and you get this like list of different visualization types. And for now, for this exercise, for the next 15 minutes, you can just go wild and just try out a couple of them. If you get stuck in one and if you're not sure what's actually going on, they all have tutorials attached. Oh no, this one doesn't work. So I hope some of them, yeah. And you actually get a video like how that visualization type works. And you also get a little description of what it can do and how it works and what it can actually visualize. So this oftentimes it needs a bit of time, and you need to get into this a little bit, like what data, like what structure works with what visualization type. And this is something you will evolve in intuition, and most probably Kimmo Maku will also give you a bit more insight of how this translation will work. But for now, you can just like go and try something. And basically, once you have like selected a type of a visualization, you can just drag and drop dimensions here. So I want years and I want generosity, and then you get a visualization down below. So it's that easy, and you can then like add other things, and based on that you suddenly, and then you can tweak it here. And I mean, this might seem confusing in the beginning, but it's actually pretty easy to work with, and I think you can get results pretty quickly once you get to know the tool a little bit. So there's a website, it's called Kaggle, and it's basically a page. I can also share this link with you. I already put a couple of filters in here, so that makes it easier to find fitting data sets. I share this with you here. And basically your task for in 2 weeks is to find a data set on the site. I basically restricted it down to any data set that is smaller than 2 megabyte. If you know what you're doing, you can also use something else, but 2 megabyte won't crash your computer. That's so it's a good size for sure to work with. And then I restricted it to a specific format, which is called CSV, which stands for comma separated values, which means that every column or every row is separated by a comma. And then they have on Kaggle, they have some kind of like rating. So I said like, hey, give me all the data sets with a rating of at least 8. So there are high quality data sets. And then you still have more over 16,000 data sets on this website. And you can search for something, and you can find data about all kinds of things that you can imagine. So, and the plan is that basically you find a data set either on this site or on any other site that you want, or if you already have a data set, and you work with it and you find a couple of different ways to represent the data and visualize it. You can use raw graphs, but if you want to use another medium, you can also do that. But that's basically the plan. Next week, we're going to have a speaker who's going to talk a bit about data visualizations. But then in 2 weeks, we basically come back together and you should all share the work that you've been doing and what you accomplished within those 2 weeks, what you got interested in, what kind of data set is it, and create a couple of images. I also wrote this down here. So that is basically the idea. I'm also happy to share the slides with you, so that might make it a bit easier for you to remember this. Does it make sense to you? I think we can just finish a couple of minutes early. And I thank you very much for being here.